Today's homework is factoring for Algebra 2. We have reviewed all the different types of factoring, and we are going to factor all of these polynomials completely. So for the first one, you have x squared plus 5x plus 6. You want to ask yourself, since this is a trinomial with a 1 in front, you're going to ask yourself, what two numbers multiply to give you x squared? So you get x and x. Then here, what two numbers multiply to give you 6, but add to be 5? And that would be a 3 or a 2. And you can write this as x plus 2 times x plus 3. Same answer. Number 19. Same thing. It's a trinomial with a 1 in front. So you want to ask yourself, think what two numbers multiply to give you 40, but add to be 22. And that would be 2 and 20. 2 times 20 is 40, and they add to be 22. 23. What two numbers, same thing, multiply to give you 24, but add to be negative 10. That would be negative 6 and negative 4. These two multiply to give you 24, but add to be negative 10. Now for 27, I would pull out a GCF, a negative 1 out. So you're left with x squared plus 1x and then minus 20. Now ask yourself, what two numbers multiply to give you x squared, x times x, and then what times what is negative 20 but adds to be a 1? That would be a 5 and a negative 4. Same with 31. Take out the negative 1 first. You're left with t squared minus 7t minus 44. So now we need to think for a second. What times what is 44? 11 and 4. And if we make this would have to be a negative 11 and a positive 4 to give you negative 7. Now for 35, let's see if we can take something out first. I see a 5 common. So if we pull 5 out, we're left with t squared minus t minus 2. And now you can further factor this trinomial. And I would get a negative 2 and a positive 1. That would give me a negative 1. 39. This one, we look at this and we say, okay, this is a trinomial, but the 1 is not in front of x squared, and there's nothing common we can take out. So this is that guess and check one. So what times what is 2x squared? Now, I want to pick two numbers here that multiply to give me 24. But the outers and the inners have to multiply and add to be negative 19. So I want them both to be a negative. So it's going to for sure be negatives. Now is it 6 and 4? So if we try, let's say 6 and 4. We get negative 12 minus 4 is not negative 19. How about 8 and 3? Let's try 8 and 3. 8 and 3 give us 24. So let's try 8 and 3 here. And this looks like it's going to work because this is going to give us negative 16 minus 3 is negative 19. So that's the work. That's the right answer for 39. 43. Again, we don't have a 1 here, so we have to guess and check. I know 2 and x. 2 and 1x. Now, what times what is 36? I've got 9 and 4. I've got 3 and 12. I've got 6 times 6. These are all the combinations. So let's try 9 and 4. Now we want it, again, negative. So negative 4 and negative 9. Let's try that. Well, this is going to give us 18 minus 4 is not going to give us negative 27. What about if we switched them? I don't think that's going to work. So if we did a 9 here and a 4 here, I get negative 8, and that's going to give us, no, that's not going to give us negative 27. Let's try the 3 and the 12. Let's see if that works. 3 and 12. Let's put a 3 here, just throwing numbers down, and 12. Oh, this looks like it's going to work. So we have negative 24 minus 3 is negative 27. So this is the right answer right there. Same thing with 47. We need to figure out what times what is 2z squared, so 2z and z. Now for this one, I want to know what times what is going to give me a negative 28. I can think of 2 and 14 and 7 and 4. Let's try 7 and 4. 7 here and 4 here. One's got to be positive and one's got to be negative. So let's put a positive here and a negative here, because we want it to be negative 28. This is going to give us 8. Oh, we got it. 2 times 4 is 8. And then 8 minus 7 is 1. Here's your answer. Worked out the first time. For 51, I recognize that I have a trinomial and these two are perfect squares. This is t and 7 times 7. And you want to make sure you have a plus sign here. Now, if you can multiply one of each of these times the number 2 and get the middle term, which you do, 7 times t times 2 is negative 4, you can get negative 14t. What you have is twins. You get t minus 7 quantity squared. Same with 55. I have a perfect square here and a perfect square here. In the product, let's see, 9z, and 2 times 2. Take one of each of these, multiply them together, times the number 2. Do you get 36? You do. So it's 9z plus the 2 quantity squared. Okay. And we have this one, 61. This is the difference of 2 perfect squares. How do I know these are perfect squares? Well, 3x times 3x is 9x squared. And 6 times 6 is 36. As long as there's a minus sign in here, and these are both perfect squares, you end up with 3x minus 6 times 3x plus 6. And where you get these are these two right here. The first two go in the first 2 spot, and the next 2 go in the next 2. Now let's see, is there anything we can take out of all 3 of these terms? I see lots of numbers here. I see a 3 I can take out. A 3 is common. So let's do that. Let's take the 3 out and see what we end up having. Take a 3 out and we're left with 4x squared plus 12x and then plus 9. Then I recognize that these are perfect squares. Numbers like 1, 4, 9, 25, 36, 40, 47, 49, 181, those are all perfect squares. So now see if the product of one of each of these, so 2x times 3 is not, 2 times 3 is 6, and then times 2 gives you your 12. So this is going to be 2x plus 3 quantity squared. That's a perfect square trinomial. For 69, I see a common 2 I can take out. These are each even numbers, so 2 can be taken out. You're left with 9b squared plus 12b and then minus 5. Now, this is a perfect square, but this is not. And plus there's a minus sign here. So this is one where you're going to have to guess and check. So let's try 3b here and 3b here. And what times what is 5? So we're going to have a 5 and a 1. One has to be positive and one has to be negative. Let's see if this works right here. 3b times 3b is 9b squared. 3b times it's negative 3b, and then plus 15b, and that gives you your 12b. So this actually worked right off. 73, I see a common 2 I can take out. You're left with 2x squared minus 11x plus 5. And again, these are not perfect squares, so I have to try to factor this the best I can. I have 2x and x. And I'm going to put a -5 here and a -1 here, because that's going to give me -10 minus 1 is -11. So this is the correct answer here. And the last one is the difference of two perfect squares, x minus y times x plus y. And we are done.